Thank you for attending this talk. I will be presenting our work today titled Hazard Integrated Understanding Security Risks in App Extensions to Team Chat Systems. I'm Mingming, a PhD student advised by Professor Xiaofeng Wang. This is joint work by researchers from Indiana University Bloomington, University of Chinese Academy of Science, and Sun Yat-sen University. So what is the team chat system? The team chat system is a software that allows team members to collaborate online. There are two main features of the team chat system. The first one is the members of the team chat system focus more on group chat than one-on-one direct message. The second one is the team chat system is decided to support collaborations such as group video, screen sharing, and project management. As shown in the right picture, a team chat system also provides many team chat apps, which can access the resource of team chat systems through APIs. During our research, we identified 12 popular team chat systems such as Slack, Microsoft Teams, Zoom, and so on, which have a combined 320 million downloads from the Google Play Store. Those team chat systems usually run their team chat app markets, which has more than 215,000 team chat apps in total, including communication, file management, developer tools, and so on. Some popular team chat apps are shown in the right picture. Considering the team members and the team chat apps in team chat systems implement two access control models to protect them. The first one is the role-based access control model, which can protect data and other information. Under this model, team members are granted access to resources based on their role in the team. For example, a general member has a low privilege who is allowed to read post message in the channel he joins, then edit and delete his own messages. The second one is the permission-based access control model, which uses a unique access token and a list of permissions to control the information a team chat app can touch. Given the two access control model for protecting a team chat system, let me introduce our threat model. We assume that the adversary is a workspace member with the privilege to create and install a team chat app in workspace. While the team chat app can take any permitted action under the current security model. Besides, the adversary will perform all attacks remotely without accessing the victim's computer and software. Considering our threat model, the question becomes whether the current access control models in team chat systems can protect data and regulate a team chat app's behaviors well. However, in our research, we found there are many security risks at the whole life cycle of a team chat app, including installations, configuration, execution, and update. First of all, let me introduce the security risks during the app install. In our research, we find three kinds of security risks of app install, including install without vetting, install without notification, and install by deception. In summary, we find 4 team chat systems do not vet at all. 5 team chat systems allow a malicious team chat app to be installed without notification, and 5 team chat systems allow a malicious team chat app to use the name and icon of another team chat app. What's more, we also find there is no any notification during app update, which opens the door to a new security risk. For example, as shown in the picture, the advisor can bypass the protecting in some team chat systems by installing a team chat app with harmless permissions, such as app mentions read, later updating it with more sensitive ones, such as channels history, chat write, and so on. Our research shows that 5 out of 12 teen chat systems are vulnerable to this app update attack. When creating a teen chat app, the developer can configure the app to promote the interactions with its hosting teen chat system and the workspace. For example, some teen chat systems provide the settings of /command, which allows a workspace member to launch an installed teen chat app by typing a command string in his chat box, as shown in the picture. The victim types the string /room and sends it. Then the room app will generate a room meeting link and post it in the chat box. It is convenient, but opens the door to a new security risk. In specific, a malicious teen chat app can claim the /command registered by a legitimate app to hijack the attempt to invoke the app, so as to replace the app and impersonate it to other team members who may use the legitimate app. Take the picture as an example. When the victim types the string /room, then the malicious room will receive this event and send a room meeting link controlled by the adversary. Among the 12 teen chat systems, we find that this risk is present on 5 systems. What's worse, we also find the /command hijacking attack on Slack can cause a privacy leak. Another interesting setting is link unfolding, which provides a customized experience for a teen chat app to generate previews for URLs posted by workspace members, as shown in the picture. If the teen chat app registers docs.googles.com as an unfolding link, then it will receive any URLs start with this prefix. Then it can post the preview of the Google Doc to the chat box. However, an adversary can use link unfolding to monitor all URLs posted in channels. For example, when a malicious teen chat app sets docs.google.com in its configuration, then the victim sends a Google Doc link to any channel. The malicious app will receive this link and send it to the adversary's server. Our analysis of the 12 teen chat systems shows that both Slack and Facebook Workplace have this vulnerability. As shown above, a teen chat app uses teen chat system API to access the workspace resource. Although there is a permission-based access control model protecting teen chat apps, we find 3 kinds of risky APIs in the teen chat system. The first security risk is access control violation. For example, a malicious teen chat app can use the risky APIs to access the resource created by a victim, although the resource is only allowed to access by the victim. To avoid this security risk, we think access control on teen chat apps should follow the least privilege principle. Considering the teen chat system supports sending private messages, so the question becomes whether a teen chat app can access private messages from any team members. However, we find some teen chat systems allow system admin to read other members' private messages. To protect private messages, We think team chat systems should clarify their choice of access control designed for sensitive user data, such as whether private messages can be accessed by the workspace admin. The last one is the URL spoofing attack. As shown in the picture, a malicious team chat app can use message posting APIs to send a spoofing URL to a channel. A victim will think it is a legitimate link, such as www.google.com. However, if he clicks on it, he will be redirected to a malicious website, such as www.attacker.com. Against the URL spoofing attack, we think team chat systems should provide a warning if the text of a presented link is different from the actual one it redirected. Based on those policies, we designed a team chat app API analysis framework. Due to the time limit, please refer to our paper for details. By using our analysis framework, we find 30 risky APIs in total. As shown in the table, 14 of them violate access control. 12 of them are URL spoofing attacks. Others can be used to read private messages. Finally, we find and reported 55 security issues, and 9 of them have been confirmed by 6 vendors. Besides, we also provide our suggestions about the risky mitigation, such as team chat systems should better define their threat model. Second one, the scope of the operations that can take place on a team chat system should be clearly specified. That's all. Thank you for your time.